Here's something worth thinking about as you settle in tonight. 200 light years above your roof, there's a world whose summer arrives like an explosion. The catalogues call it HD 80606b, and it rides the most violent road of any planet ever found. For 100 days of its year, it drifts in cool quiet, about as far from its star as you are from yours. Then it falls. In a few racing days, its sun swells 30 times wider. The light climbs to 1,000 times what Earth gets at noon. The air heats by 700 degrees in 6 hours, and winds of 11,000 miles an hour tear around the globe. Then it climbs away, cools, and forgets. It repeats every 111 days, and astronomers have watched it live. Nobody could explain how such a world exists, because planets are not born like this. Something made it this way. Tonight, we will embark on that journey together to figure out exactly what is happening on this planet and how it was created. If you enjoy falling asleep to the wildest worlds the universe makes, do me a small favor and hit that subscribe button. It genuinely helps this channel grow and lets me keep making these deep dives for you. Also, tell me in the comments where in the world you're falling asleep tonight. For now, dim the lights and settle in. Let your shoulders come down and your jaw unclench, because nothing in your sky will swell or blaze tonight. Your world keeps the gentlest road in the sky, and the only falling left is yours, into sleep. Have you ever wondered what you'd see, hour by hour, above the clouds as a sun grows from a bright coin into a furnace filling the sky? How a planet ends up with a year that's all autumn except 2 days of fire? Why your seasons have almost nothing to do with how close Earth stands to the sun? How a teaching telescope in a suburb, dodging clouds, caught this giant crossing its star's face? What the tides of a too-close star do to a world 4 times Jupiter's weight? Why this world's ordeal has an ending already written into it? And the strangest one of all, worlds are born on calm, round roads, every one of them. So what, or who, bent this one into a blade? The prime suspect has been in plain sight, in every photograph ever taken of the scene. Tonight, we'll catch it in the act. But first, the ride itself. Let's begin. The strange thing about the fall is how gently it begins. Picture yourself hovering high above the cloud tops of this world on the first day of its year, which is to say, at the very top of its long swing, the farthest it ever gets from its star. It's lovely up here. Genuinely, disarmingly lovely. The star hangs in a black, star-salted sky, looking much the way your sun looks from Earth on a clear winter afternoon. A small, bright, well-behaved disk, warm on the face of the clouds and asking nothing. The planet itself rolls beneath you in soft bands of cream and amber, a giant of the same family as Jupiter. And the cloud tops up here run merely cold. The cold of a hard winter night, the kind you dress for rather than fear. Everything is slow. The world is coasting near the top of its arc, and like any swing at the top of its rise, it has traded almost all its speed away. It hangs. It drifts. If you didn't know the road ahead, you'd call this one of the calmest places in the galaxy. And here's the thing to hold on to all night. For most of this world's life, you'd be right. The calm isn't a trick. It's real, it's most of the year, and it's home. The fall is real, too. Both things are true at once, the way they often are, and the two of them together are why telescopes all over Earth keep turning back to this one modest star in the north. For the first several weeks, nothing seems to happen, which is exactly how the road is built. The star brightens so slowly you'd need instruments to swear to it. The world slides inward at a walker's version of orbital speed, gathering pace the way a dropped feather gathers pace. And the sky stays black, and the clouds stay cold, and the days, each about 40 hours long, tick past without ceremony. If you kept a journal up there, whole pages would read the same. Star a little brighter, air a little livelier, nothing to report. A month in, the star has visibly grown, from a bright coin to something more like a doorknob held out at arm's length, and the light on the clouds has turned from winter afternoon to summer morning. Still gentle, still fine, but the feather is falling faster now, and this is the part of the story where your stomach starts to know something the scenery hasn't admitted yet. Because the swing doesn't pay out its speed evenly. It saves almost everything for the bottom. The world spent weeks ambling through the top of its arc, and it will spend the bottom of that arc at a sprint. And the two of those facts are the same fact, wearing different clothes. Slow up high, fast down low. Every child on every swing has felt the rule in their belly. Out here, the rule has a planet in its hands. Want to feel the fall in your own solar system's terms? Map it onto home. At the top of the swing, this world hangs at nearly the distance where Earth lives. That's the balcony. That's where the whole long autumn happens. As the dive steepens, it drops past the distance where Venus rides, and the light doubles. It keeps falling. It cuts inside the road of Mercury, the innermost world we have, the scorched little sprinter, no planet of ours undercuts. And it keeps falling. By the bottom of the arc, it's running at 1/10 of Mercury's distance, deep inside territory where our solar system keeps nothing at all, no world, no moon, not even a comfortable comet. Think about what that means. If you drop this planet's road into our sky, its year would begin out near your window and end brushing the fire itself. It commutes, twice a lap, across the entire span of what we'd call the inner solar system, and then some. No world you've ever heard of does anything like it. Your Earth's whole yearly wander, top to bottom, wouldn't move it one band's width on this planet's chart. The scale of the swing is the first thing astronomers check when they doubt their own instruments, and it survives every check. It really is that long a fall. It really does happen every 111 days. The last week is when the sky stops being reasonable. The star is now unmistakably wrong, swollen past anything your instincts will accept. A glaring disk several times the width of the sun you grew up under, and it's growing by the day. Then, by the hour. The world is properly diving now, cutting inward across distances that took weeks up at the top, and everything below you begins to answer. The cream and amber bands sharpen and streak, new clouds boil up, catch the flood of light, and burn away. The night side, when you swing across it, is no longer fully dark. Its high hazes, glowing dull red with borrowed heat, like the coals of a fire that hasn't been lit yet. On the last day, the numbers all leave the page at once. The star stands 35 times wider in the sky than yours does. A circle of fire you could just about hide behind your outstretched handspan, pouring down 1,000 times the light of an Earth noon. The upper air, which began this fall at about 500 degrees in its warmer layers, is climbing past 1,200, and it managed most of that climb in 6 hours. 6 hours. Lunch to midnight. Your own planet's air has never once, in 4.5 billion years, done anything remotely like it. Here's a fair question to ask right about now. Why does the world survive this at all? Why doesn't a yearly blast like that simply cook the whole planet through, lap after lap, until nothing is left to burn? The answer is depth. The fire is enormous, but it's also shallow. Starlight can only strike the top of an atmosphere, and this atmosphere goes down and down and down. Thousands of kilometers of ever thicker air pressing toward a core that has never once heard about summer. Think of the sea on a hot day. The surface film warms. Dive down an arm's length, and the heat is gone. The plunge scorches this world's surface film, the upper decks where the clouds live and the telescopes look, and the deep interior, which is nearly all of the planet, rides through the fire unbothered. Cold and dark and enormous, 4 Jupiters of ballast that no single day can touch. That's why the fever breaks so cleanly on the climb out. The skin flashes hot, the skin cools off, and the great body underneath barely registers the whole affair. It's a strange kind of toughness, and worth holding on to. The most brutal weather in the catalogue is, from the planet's own point of view, skin deep. The world under the storm is older than the storm, bigger than the storm. And, in the way that giants often are, almost entirely asleep through it. And the world, to its credit, does not simply take this. It answers. Air that's heated that hard, that fast, on one side only, does what air always does, which is move, except here, the moving is like nothing in any sky you've known. A wall of wind is born on the day side and goes tearing around the planet at 11,000 miles an hour, several kilometers every second, hypersonic by any Earth standard, a global storm assembling itself in a single afternoon. Below you is no longer a landscape of bands, but a furnace of shear and glare. Clouds shredding, hazes flashing to vapor. The whole visible face of the world rewritten by the hour. Meanwhile, the planet itself is moving faster than anything you've ever ridden. Down here at the bottom of the swing, it's doing better than 200 kilometers every second, 4 times the best Mercury ever manages, fast enough to cross the whole Atlantic between 2 beats of your heart. And so the terrible part, the part the title of tonight promised, turns out to be almost merciful in one respect. It's quick. The world whips around the bottom of its arc, rounding the star in about a day, closer to it than 1/10 of Mercury's distance, moving too fast to linger in the fire it came all this way to meet. The star swings across the sky, the pull turns, and the world is outbound, flung back up toward the cold, carrying its brand new storm along with it. The climb out is the fall played backward, at the same forgiving pace. Within days, the star has shrunk from a furnace to a lamp, and the flood of light has fallen away by half and half again. The globe-spanning winds, with nothing driving them anymore, begin to spend themselves. The hazes that burned away start to reform in the cooling air, stone and mineral vapors condensing back into cloud, the world literally repainting itself. Astronomers who studied the heat of this passage found that the planet rings for days afterward, the atmosphere sloshing and settling like a struck bell slowly going quiet. And I don't know a better image for it than that. A bell, rung once per year, hanging in the dark, humming itself back to sleep. By the second week outbound, the sky is reasonable again. By the first month, the journal entries have gone back to their old refrain. Star a little dimmer, air a little calmer, nothing to report. The world coasts up into the long, cool autumn that is most of its life, slowing as it climbs, and near the top of the swing it hangs again, drifting, gentle, 100 and some days from the next fire, and completely unbothered by it. That's the ride. That's 1 year on the most brutal planet we've ever found, and now that you've been around it once, you're ready for the real story, which is everything else, where this world actually is, how anyone on Earth ever came to know it, and who set its swing so high in the first place. So, first, the address, because it's a better one than you might expect. This is not some exotic corner of the galaxy. If you know the Big Dipper, the great saucepan of the northern sky, the one shape almost everyone's grandparent pointed out to them once, then you already know the neighborhood. Off the bowl of the Dipper, in the constellation of the Great Bear, there's a patch of sky where a pair of good binoculars, on a dark night, away from the streetlights, will show you a faint, yellowish star that no catalogue bothered to name, only to number. That's it. That's the star. The light hitting your binoculars will have left it around the time your town was laying its first railway. 2 centuries and a little more compressed into a pinprick. And the pinprick is a sun quite like yours, a touch smaller, a touch cooler, a touch richer in the metals that planets are made from. Nothing about it would ever stop a survey. It has no drama to offer a telescope, no flares, no strangeness. Just steady, respectable, middle-aged starlight. The most violent planetary road we know of runs its laps around one of the most ordinary-looking stars in the north. And that's worth a slow breath in itself. The sky doesn't label its strange places. You can stand in your garden, sweep your binoculars across the bare, pass right over this star, and never feel a thing. And since the star only has a number, it's worth knowing where the number came from, because there's a lovely piece of history folded into those two little letters. HD stands for Henry Draper, a doctor and amateur astronomer from more than a century ago who pioneered photographing the stars, and who died young. His widow, wanting his name to outlive him, funded a project at the Harvard Observatory to catalogue the sky, and the work fell to a room of women astronomers hired to measure and classify star after star from glass photographic plates. One of them, Annie Jump Cannon, personally classified hundreds of thousands of stars, at a pace her colleagues could hardly believe, a star every few seconds, hour after hour, year after year. The great catalogue that resulted carries Draper's initials, and nearly every bright star you can find with binoculars carries an HD number from her hands. So when you read the name HD 80606, you're reading a memorial to a man, written out 250,000 times by a woman who never got a telescope of her own to run. She catalogued tonight's star as a matter of routine, one line among thousands, with no way of knowing what swung around it. Nobody knew anything swung around anything then. The catalogue was a list of lights. It took another century to learn that the lights have families. Would you like to find it yourself someday? You could, and here's roughly the way. Start with the Big Dipper, which you can find. Everyone can. Those 7 stars are the one signpost the North gives away free. The Dipper is only the bright heart of a much larger constellation, the Great Bear, whose fainter stars sketch out pores and a nose that most city skies hide. Tonight's star sits in among those faint parts, far below naked eye reach. So you'd need binoculars, a dark night, and a star chart, the paper kind or the phone kind. And you'd need the old skill the charts teach. Star hopping. You find a star you know. From it, you hop to a fainter one you can name, and from that one to a fainter one still, checking the pattern against the chart at every hop, until the field in your binoculars matches the field on the map. And there, that one, the yellowish point just there, is a sun with a twin, and the wildest planet on record. What do you actually see? A dot. An utterly ordinary dot. That's the whole reward, and people drive hours into the dark countryside for it, because seeing the actual light with your actual eyes changes something no photograph changes. The dot is real. The swing is really happening, right there, behind that grain of light. Some night, years from now, you may find yourself checking, but look a little closer, the way the survey photographs always have, and the star turns out not to be alone. There's a second star beside it, close enough in the eyepiece that the two read as a neat little double, and this second star is no passing stranger. It's a twin, the same size, the same warmth, the same age, the two of them condensed out of the same cloud in the same era and bound to each other ever since, a pair of suns keeping house together for billions of years. They stand well apart, as twins go, more than 1,000 times the distance between Earth and the Sun. So from the planet's sky, the second sun is not a second day. It's a spark. A single brilliant point, bright enough to read by on the darkest night, casting the faintest second set of shadows. A porch light left on across an enormous garden. For 100 years of photographic plates, that second star was a piece of scenery. It appears in every image of the system ever taken, patient and unremarkable, the quiet sibling of a quiet star. Keep it in the corner of your eye all night. Tonight is, among other things, a mystery story, and the mystery has exactly one suspect within reach, and it has been standing in plain sight, in every photograph, the entire time. How far apart do the twins actually stand? Far enough that the word twin starts to feel wrong, and that's exactly what makes tonight's mystery so strange. More than 1,000 times the distance from Earth to the Sun separates them. Light itself, the fastest thing there is, needs most of a week to cross from one sun to the other. From the planet, the second star delivers no warmth worth the name, no daylight, no seasons, nothing you could feel on your skin. It's a lantern across a lake, beautiful and useless. And gravity, at that distance, is weaker than weak. The twins' pull on the planet amounts to less than a whisper of a whisper, so faint you'd be forgiven for leaving it out of the sums entirely. Most sums do. A star most of a light week away can't lift a feather here. Hold that thought right next to this one. Tonight's planet rides the most violently reshaped road in the catalogue, and the only other significant body anywhere in the system is that faraway, feeble, irrelevant-looking twin. One scene, one anomaly, one bystander. Every detective story you've ever read has taught you what to do with a setup like that. And every detective story is right. But the how of it, how a whisper across a light week bends the road of a world 4 times Jupiter's weight, is one of the finest tricks in all of gravity. And it deserves its own act. It will get one. Now the world itself, properly introduced. It's a gas giant, Jupiter's family, but built heavier, about 4 times Jupiter's weight packed into nearly the same size, because giant planets have a strange rule to them. Pile more matter onto one, and it mostly doesn't get bigger. It gets denser, the deep interior squeezing tighter under the new load, so a world of 4 Jupiters wears roughly 1 Jupiter's coat. There's no surface anywhere on it, no ground in any sense you could stand on, just clouds over deeper, clouds over air compressed past the point where air and ocean stop being different things. Its gravity, up where the clouds are, runs about 10 times yours, enough to make your arms feel like luggage. Its day, the time it takes to turn once, is about 40 hours. Astronomers reckon a leisurely spin with an unsettling explanation we'll come back to before the night's out. And its year, the whole swing we rode together, top to bottom to top, takes 111 days. 3 of its years fit inside one of yours, with change left over. Hold those 2 numbers side by side a moment, because they're the whole character of the place. A year of 111 days, a summer of about 2. This is a world that is almost entirely autumn, an endless mild falling season wrapped around a single savage exception. And if that ratio seems backward for something billed as the most brutal planet ever found, good. That's tonight's first real lesson. And we'll earn it slowly. And then there's the road it travels, which is the thing that made it famous. So let's draw it properly. Take a dinner plate and put a candle at the center. That's roughly your solar system's style. Worlds on rings, the fire in the middle, every lap the same as the last. Now slide the candle out from the center, past the halfway mark, past the rim of any reasonable design, until it sits just inside the very edge of the plate. Then draw one long oval that hugs nearly the whole plate's width. That's this world's road. At the far turn, the top of our swing, it stands almost as far from its star as Earth stands from the sun. Out where the light is polite. At the near turn, it passes its star 30 times closer, down inside 1/10 of Mercury's distance, close enough that the star's outer glow practically brushes its sky. No planet in our solar system travels anything like that shape. Nothing here even gestures at it. To find its like around our own sun, you have to give up on planets entirely and look at comets, the snowballs that fall in from the deep cold, whip around the fire, and flee back out for decades. That's the road this thing is on. A comet's road. Except a comet is a mountain of ice, a rounding error with a tail. And this is 4 Jupiters of world, a planet outweighing everything else in its system combined. Running a snowball's errand twice a season, forever. When astronomers first saw evidence of it, they did what you'd hope careful people would do. They didn't believe it. To feel the disbelief properly, you need to know how anyone finds an invisible planet in the first place, because nobody has ever simply seen this world. It's far too small and far too dim beside its star, a firefly perched on a lighthouse 200 light-years off. What astronomers watch instead is the star, and what they watch it do is wobble. A star and its planet are partners in a slow dance. The planet swings wide, the star sways small, both of them circling their common balance point, and though the star's sway is tiny, starlight gives it away. As the star sways toward you, its light compresses a whisper toward the blue. As it sways away, the light stretches a whisper toward the red. It's the same trick the universe plays on ancient galaxy light. The stretch we've met on other nights. Only here it's minuscule and rhythmic. A pulse in the rainbow, back and forth, lap after lap. Spread the starlight out. Read its barcode lines finely enough. And you can clock a star's sway down to walking pace. From the sway's size, you get the planet's heft. From its rhythm, the length of the planet's year, and from its shape, and this is the part that matters tonight, you get the shape of the road. Warmth light, while we're gathering tools, deserves its 1 minute too, because the second half of tonight leans on it. Everything warm glows, not poetically, physically. Your own body, right now, under the covers, is shining, pouring out invisible light in exact proportion to its warmth, and so is the kettle, and the radiator, and the dog. Eyes can't see that glow, but instruments can, and here's the gift in it. The glow is a thermometer. Read how much warmth light a thing gives off, and you've read its temperature from any distance without touching it. That's how a nurse's forehead scanner works from an arm's length. Build the scanner exquisitely well, cool it down, fly it above the blurring air, and it works from 200 light-years. Do you see where this goes? A star and its unseen planet arrive in the telescope as one point of light, but the planet's share of that point rises and falls as the planet heats and cools. Watch the point's warmth closely enough, over hours, and you are taking an invisible world's temperature in real time through its star's glare. Hold on to that trick. Later tonight, someone is going to point such a thermometer at our planet on the worst day of its year. And what the needle does in 6 hours became one of the famous charts in astronomy. A planet on a circle produces a sway as smooth and even as breathing. A planet on a blade produces something else entirely. Before we read that signature, give a thought to how absurd the measurement itself is, because it's easy to say wobble and miss the miracle. A star is a furnace wider than 1,000,000 Earths. A planet, even a heavy one, sways it at something like walking pace. So the job is this: stand on a spinning, orbiting planet of your own. Point an instrument across 200 light-years of dark, and clock a furnace strolling. The tool that does it is a spectrograph, and the best way to picture one is as the world's most serious ruler laid against the rainbow. Starlight goes in, gets fanned out into its colors, and the barcode lines fall across that ruler at positions known to exquisite precision. When the star sways, every line slides along the ruler by a hair's breadth of a hair's breadth, and the sliding is the walking pace. Read directly. It took a century of craft to build rulers that steady, and the hunters guard them like hearths. Temperature controlled, vibration proofed, checked nightly against reference lamps, because the whole science rests on the ruler not drifting while the sky does, and then it takes patience. Because one reading is nothing. You need laps. Seasons of them. The bear comes around, the star gets measured, the year turns, the star gets measured again, until the sways stack into a shape no accident could fake. Planet hunting looks like stargazing from the outside. From the inside, it's closer to lighthouse keeping. The same star, the same ruler, the same quiet logbook for years, waiting for the sea to confess. The people watching this particular star were the planet hunters of Geneva, the Swiss team that had, only a few years earlier, found the very first planet ever discovered around another ordinary sun, using a telescope in the hills of southern France. You should feel the era for a moment. When this story starts, planet hunting was brand new. The known worlds beyond our sun numbered a few dozen. Every single one had been a surprise. And the biggest surprise was already in hand. The very first find, a giant world skimming its star on a 4-day lap, had broken the textbooks in one stroke, because our best theories said giants belonged in the cold outfield where ours live. Nobody yet knew what was normal out there. Every new star was a lottery ticket. And still, when this one came up, it read like a misprint. The star's sway refused every circle the team fit to it. It would drift, gentle and slow, for month after month, barely moving, and then lurch, hard, briefly, as if grabbed, and settle back into its long drift. There's only one honest way to read a signature like that. The planet spends most of its year far away, tugging softly, then dives in close and yanks its star round the bottom turn before racing back out. The drift was the long autumn, the lurch was the fall. The fit that finally worked traced the most stretched planetary road anyone had ever measured, and for years afterward it held that record outright. It remains, to this night, the most extreme road of any world we can watch cross its star. Careful people, faced with a reading like that, check the instrument before they trust the story, and they did. They gathered more laps. The lurch came back on schedule, the same violent little signature. Every 111 days. Year after year. It wasn't the spectrograph hiccuping. It wasn't a second star hiding in the data. That idea has its own fingerprints, and they weren't there. It was a planet, 4 Jupiters strong, on a comet's road, and in 2001, the team published it, and the field leaned in and blinked, because you have to understand what a result like this does to a young science. It doesn't just add a strange specimen to the shelf. It moves the walls of the possible. Every theorist who had ever sketched how planets form had drawn, without even thinking about it, a calm, flat nursery and a set of nearly round roads, because that's what our solar system taught, and our solar system was the only one anyone had ever had. Round roads weren't a finding. They were an assumption so old, it had stopped being visible. And here was a world whose road crossed nearly its whole system twice a season, a thing none of the sketches allowed, orbiting a star so ordinary you'd pass over it in binoculars. Nature, it turns out, files no paperwork. It doesn't ask whether a planet like this is allowed. It just builds one, sets it swinging, and waits a few billion years for somebody curious, with a good spectrograph, to notice. And once the walls of the possible had moved, a strange thing happened, the thing that always happens. The sky turned out to have been full of hints all along. In the years that followed, the hunters found more giants on stretched roads, a whole loose family of them, none as extreme as tonight's champion, but enough to draw a pattern. Eccentric Jupiters. The field took to calling them worlds whose roads swing wide and dive close, scattered through the catalogues, like bent nails in a drawer of straight ones. Each one is a system with a history, a place where something, a sibling giant, a passing star, a leaning companion, once shoved a world off its birth road and left it swinging. Astronomers began to read orbit shapes the way geologists read rock layers, as records of old violence. And the roundness of a road became a biography in one number. Here's what that reframing does, and it's tonight's quiet gift to you. It means our own solar system's calm is not nothing. 8 worlds, all on nearly round roads, all in one flat plane after 4.5 billion years, is a peace treaty that has actually held. You live inside an unusually gentle history. The bent nails elsewhere are how we finally learn to see it. And the most bent of them all, the one that taught the lesson first and hardest, is the planet whose year you rode at the start of tonight. Now, I keep saying stretched, and it's time to make that word honest, because there's a whole ladder of stretch in the sky, and climbing it slowly is the best way to feel where tonight's world actually sits. Astronomers measure the stretch of an orbit with a single number they call eccentricity. But you don't need the number. You need 2 pins and a loop of string, which is how gardeners and draftsmen have drawn these shapes forever. Push 2 pins into a board, drop a loop of string around them, pull the loop tight with a pencil, and sweep it around. Out comes an oval. If the pins sit together in the middle, the oval is a circle, and the star, in any orbit, lives at one of the pins. Now slide the pins apart. The oval stretches, and the pin that holds the star slides away from the center toward one end. Slide the pins far enough apart, and you get something long and narrow as a leaf, with the star sitting far off center, crowded down near one tip. Every orbit in the universe is somewhere on that board. The whole variety of the heavens, every moon and planet and comet and star pair, comes down to how far apart somebody slid the pins. So who slides the pins? What decides, at a world's birth, how stretched its road will be? The answer is the nursery itself, and it's a tidy one. Planets condense inside a disk of gas and dust, and a disk is a crowd. A young world trying to ride a stretched road through a crowd gets bumped, dragged, and jostled at every crossing, and each bump bleeds away the stretch. The gas acts like water in a channel. Try to swim across the current, and the current straightens you out. Give it a few million years, and the disk has done to every young orbit what rivers do to leaves, gathered them all into the same smooth flow, round and flat and orderly. That's why round roads aren't a lucky accident. They're enforced, everywhere, by the physics of being born in a crowd. And that's also why a grown planet on a blade is such a glaring clue. The enforcement only works while the gas lasts. Once the disk clears, a few million years in, the river dries up, the current stops, and from then on, any orbit that gets bent stays bent, with nothing left to straighten it. Read as a detective would. A stretched road on a mature planet means the bending came after the nursery closed. Late violence, not rough birth. Keep that. It's the fact the whole verdict rests on. Your own world's pins are, for all purposes, touching. Earth's road is so nearly a perfect circle that no drawing you've ever seen does it justice. And here's the detail that surprises almost everyone the first time. Earth is closest to the sun in early January. The depths of northern winter, if closeness ran your seasons, January would be high summer in the north. And it isn't, because across our whole year the distance to the sun changes by only a few parts in 100. The sunlight shifts by less than the difference between a clean window and a slightly dusty one. You have never once felt it. Your seasons come from the planet's tilt, the slow lean of its axis toward and away from the light, distance having nothing to do with it, and that's the mark of a truly round road, distance so constant it goes unnoticed for a whole civilization's history. Climb one rung up the ladder, and you reach Mercury, our local rebel, whose noon sun swings well over double in brightness between the near and far ends of its year. Climb past it to Pluto, whose road is stretched enough to cross inside Neptune's for years at a time, so that the far kingdom's borders genuinely interleave, and there the planets of our system stop. That's our whole native range, from Earth's serene circle to Pluto's tilted amble. To climb higher, you have to leave planets behind. The next rungs belong to the comets, and they show you what stretch really means. The famous one, Halley's, falls in from out past Neptune's distance, whips around the sun inside the road of Venus, and climbs all the way back out. a round trip of decades, of which the fiery inner crossing takes only months. Its pins are slid so far apart that the sun sits pressed nearly against one tip of the oval, and if you drew its road on our dinner plate, the candle would stand practically at the rim. That, almost exactly, is the shape tonight's world rides, and honesty makes me tell you that Halley's road is, by the raw geometry, even a touch stretchier. So why is a snowball's road unremarkable and a planet's road a scandal, weight, and consequence? A comet is a mountain of dirty ice, a crumb the sun barely notices, warmed to a lovely tail and no further. Send 4 Jupiters down that same road and everything changes. The star hauls at it hard enough to knead its insides. Its own gravity drags a huge atmosphere through a yearly firestorm, and its passage swings enough weight to bully anything else that ever tried to live in that system. A comet on a blade is a visitor. A super Jupiter on a blade is a resident wrecking ball. And the sky, as far as we can see, holds nothing else quite like it. When you picture where this world sits on the ladder, put it above every planet we've ever confirmed, on a road it crosses its star's face from, up on the comet rungs, alone, holding its 4 Jupiters of luggage. Is there a top rung? There is, and it's a door, and you've already been through it on another of our nights. Keep sliding the pins apart, stretch the oval longer and longer, and at some point the far end of the loop stops closing. The string, so to speak, breaks. The road opens at one end, and a body on an open road makes exactly one visit, whips around the star exactly once, and leaves forever, never to return. That's the road the interstellar visitors travel. The strange guests from other suns we met on our night with the golden telescope, passing through with no return lap in them. So the ladder of stretch runs all the way from your world's serene circle, up through Mercury's wobble and Pluto's amble, past the comet's long loops, to tonight's planet near the very top of the closed rungs, and then past it, through the open door, to the roads that never come back at all. One family of shapes, drawn with 2 pins and a loop of string, covering everything from your calendar to a visitor from another star. Tonight's world lives just inside the door. Its road stretches almost to breaking, almost to the shape of leaving, and then closes, barely, and holds. It is, in the geometry's own terms, a departure that never quite happens forever. A world that swings out to the very edge of goodbye, twice a season, and comes home every time. Let's walk its calendar properly then, because the shape of a year tells you more about a world than almost anything else. And this year is shaped like nothing you've ever lived. Say the year begins at the top of the swing, the far turn, day 1. From day 1 to somewhere past day 50, almost nothing changes. This is the season we hovered through earlier. The long autumn, the star a companionable coin, the clouds cold and calm, and there's a beautiful piece of old physics hiding in why this season lasts so long. A body on a stretched road doesn't spread its time evenly around the loop. It lingers where it moves slowest, and it moves slowest where it's farthest, up at the top. So the world spends the overwhelming majority of its life in the mildest part of its road, drifting through the wide, cold top of the oval, and positively flees through the bottom. Out of 111 days, 100 and some belong to that slow high country. Around 2, give or take, belong to the fire, 2 days. The most brutal planet we've ever found. Budgets less than a 50th of its year for the brutality. And I want to hold that up against the title for a moment, gently, because there's a bedtime lesson in it if you want one. Even here, on the most violent road in the catalogue, calm is the rule, and the fire is the exception. The universe, when it built its harshest year, still made it mostly quiet. The rule behind that lopsided calendar is 400 years old, and it's worth meeting properly, because it's one of the first great laws anybody ever read out of the sky. Johannes Kepler, Working with the finest naked eye observations ever taken, notice that a planet on an oval road doesn't just speed up when it's near its star. It speeds up by an exact, beautiful rule. Picture the string again, running from star to planet, and imagine it sweeping out area as the planet moves, like a windscreen wiper sweeping a pane. Kepler's rule says the wiper sweeps equal areas in equal times, always, everywhere on the road. Near the star, the string is short, so to sweep its quota of area, the planet must tear along. Far from the star, the string is long, and a tiny lazy drift sweeps the same area just fine. That's the whole secret of the 109 quiet days. It's not that the world lingers up there out of any preference. It's that the geometry itself pays out time generously at the top of the swing and snatches it back at the bottom. Your own world obeys the same rule, by the way, in miniature. Earth genuinely moves faster in January than in July, quicker in the northern winter, lazier in the northern summer, and the difference is real enough that the seasons aren't quite equal in length. You've lived inside Kepler's rule your whole life. Nobody notices on a round road. On a blade, the rule runs the whole show, but the exception, when it comes with arithmetic no world should have to do. Light falls off with distance, quickly, by the square of it, so bring a world 30 times closer to its star, and the light lands not 30 times harder, but nearly 900 times harder. Every acre of cloud that was catching one lantern's worth of warmth at the top of the swing catches a bonfire's worth at the bottom. At the near turn, the flood running down onto those clouds reaches about 1,000 times the light your world gets at high noon, which is a number I can't make feel like anything until we do this. Imagine your own sky holding 1,000 suns. Not one bright point, but the whole blue dome, replaced with glare, shadows erased, the difference between noon and any other noon you've known, roughly the difference between one candle and a chandelier the size of the sky. Now notice that the world receiving this has no ground to bake, no rock to hold the story. It's atmosphere all the way down, and air answers heat with motion. And notice one more mercy in the arithmetic. The same law that makes the fall so vicious makes it brief. The punishing zone is small, just the tight turn at the bottom, and the world crosses it at the fastest speeds it will touch all year. The road's cruelty and the road's kindness are the same curve, read in two directions. If Earth were ever put on such a road, our oceans and air would not last the first lap. This world, built of storm from the start, takes the lap every 111 days and comes out the other side merely rearranged. Try the calendar on just for a moment before we leave it. What would you do with a year that was all autumn? A year where the weather report read the same for 100 straight days, cool, dim, calm, and then, printed right there in the almanac, 2 days marked in red, exact to the hour, generations in advance? There's something in that arrangement that human farmers and sailors would actually recognize. We've always lived by hard dates in soft seasons, the frost that ends the growing, the tide that opens the harbour, the monsoon that arrives, near enough when the grandmothers say it will. A world with one perfectly punctual firestorm per lap is our own almanac logic, stretched to its limit. Everything on such a world would be built around the red days. Every question would be one of two questions. How long since the fire? Or how long until it? And the long middle of the year, the part that's just cool and dark and uneventful, would be the treasure, the way it's always been the treasure. Here's the almanac's last line, and then we'll move on. Tonight, on your world, there are no red days printed anywhere. Your almanac is the boring kind. Weeks of ordinary weather, mild variations, nothing scheduled to swell or fall. People pay for boring almanacs with their whole civilizations, and yours is paid up. And the calm outside your window tonight is the dividend. Which brings us to one of the finest nights in the modern history of watching, the night humanity took this world's temperature while the fever spiked. It happened thanks to a smaller, older space telescope, Webb's little grandmother in a way. An infrared eye called Spitzer, launched years before and set on a gentle road of its own. It trails Earth around the sun, falling a little farther behind us every year, like a grandparent content to walk at their own pace. Spitzer read the sky in warmth light, the invisible glow that heat gives off, which meant it could do something almost cheeky. It could measure the warmth of a planet it couldn't see. Star and planet together arrive in the telescope as a single point. But that point's warmth rises and falls as the unseen planet heats and cools and hides, and buried in those tiny changes is a weather report from another solar system. So in the autumn of 2007, astronomers did something that had never been done. They pointed Spitzer at that modest star in the Great Bear and held it there for 30 hours straight, through the bottom of the dive, through the near turn itself, and they caught the whole thing. The plunge, live, beginning to end. Feel the stakes of that request for a second, because telescope time is the rarest currency in astronomy. And 30 continuous hours of a space telescope is a small fortune wagered on a forecast. The team had done their arithmetic. They knew from the wobble work when the near turn would come to within hours. What nobody knew was whether the readings would show anything cleanly, whether the planet's warmth would rise out of the noise, whether the whole gamble would come home as a flat, useless line. That's the part of science the documentaries skip, the night before, the quiet version of suspense where you've spent your fortune and the sky hasn't answered yet. Then the hours started arriving. The combined point of star and planet, watched in warmth light, began to brighten, gently, right on schedule, as the unseen world swung down toward its fire and its heated face rotated into view. Somewhere in the middle of the vigil came the eclipse, the little notch of the planet slipping behind the star, gift wrapped inside the larger show, and then the brightening steepened into the spike of the near turn itself. You can imagine the room. Nobody in it could see a planet. Everybody in it was watching one, the way you watch a kettle. You can hear, but not see. And the kettle, 200 light years away, was coming to the boil exactly when their equations said it must. What came back is one of the great weather charts ever drawn, and it fits in a sentence. Over about 6 hours, the face of the planet went from around 500 degrees to over 1200, 6 hours. The time between your lunch and your midnight. And in it, a whole hemisphere of a world 4 times Jupiter's weight heated by 700 degrees, the fastest large-scale temperature swing ever recorded on any planet, anywhere, including every oven of a world found before or since. The team that led the work, headed by an astronomer in California whose specialty is the weather of other worlds, ran the readings through their models and watched the models describe a storm with no living precedent. Air on the starlit face flashing hot and bursting sideways. Winds accelerating to several kilometers a second, 11,000 miles an hour. A heat-driven shockwave setting off around the globe like a rumor. And then, as the world swung out and away, the readings showed the other half of the story, the part I find gentler every time I think of it. The fever broke. The glow subsided over the following days. The winds spent themselves against the planet's own vastness, and the atmosphere rang and sloshed and slowly settled, a struck bell going quiet. One of the scientists reached for that exact image, a bell rung by starlight once a year. Since then, the golden telescope from another of our nights together has taken its own turn at the vigil, watching a full plunge hour by hour with far sharper senses, and its readings are still being argued into shape. The bell rings on schedule. We now gather to listen. Spitzer itself deserves a farewell line here, since tonight leans so hard on its finest hour. It was a small telescope by any modern measure, launched on a budget, cooled by a tank of liquid helium that everyone knew would one day run dry, and set on that earth-trailing road because the road was cheap and quiet. The helium lasted years longer than promised. When it finally ran out, the telescope warmed by a few degrees and kept working anyway, half blind and stubborn, for another decade. And all the while, it drifted farther behind Earth, a little more each year, its calls home growing fainter, until the day came when pointing its antenna back at us cost more power than the old machine could spare, and the operators, with real ceremony, told it to sleep. It's still out there tonight, on your own side of the sky, following Earth around the sun like a dog that fell behind on a long walk and never stopped trotting. It will trail us for ages. And its fever chart of tonight's planet remains one of the great single nights of measurement in the history of the science, the first time our species watched weather ignite on a world it cannot see. Machines get remembered for their best night. That was Spitzer's, or one of them, and the planet it measured will still be ringing its yearly bell long after the little telescope has drifted all the way around the sun and, in some unimaginably distant season, catches back up to the planet that forgot it. And listen is truly the word, because everything in that chart was heard, so to speak, in warmth, from a planet no one has ever seen as more than a dip in a light curve. It's worth sitting with how strange and how strong that is. 200 light-years away, around a star you need binoculars to find, a storm the size of 4 Jupiters comes and goes in a day, and a species of curious mammals catches the whole event through a telescope the size of a small car, trailing their planet like a dinghy. No photograph, no probe, just warmth, read carefully, and centuries of patiently learned physics turning a flicker into a forecast. When people say astronomy is about looking, they're underselling it. It's about wringing whole worlds out of almost nothing. Honestly, checkably. And the near turn of this planet was one of the first times our species wrung out a world's actual weather. In real time, as it happened. The fever chart from that night hangs, in a manner of speaking, in the Field's family album now. And it did one thing more, almost as an aside, that turned out to matter enormously. Hidden in those 30 hours was a small, clean dip of a different kind. The planet slipping directly behind its star. An eclipse, which told the watchers something that made several of them sit up very straight. If the geometry allowed that, then once every lap, this world might also cross in front. Understand what a crossing would be worth, and you'll understand the small worldwide fever that followed. When a planet passes in front of its star, the star dims, barely, for as long as the crossing lasts. And that little dip is the most generous gift in all of planet hunting. The depth of the dip tells you the planet's true size. Because a bigger world blocks more light. Size, plus the weight you already knew, gives you density, which tells you what the thing is actually made of. The exact timing sharpens the whole map of the road, and down the line, crossings open stranger doors still. Doors we've walked through on other nights, starlight filtering through the crossing world's air and carrying home its recipe. A wobble tells you a planet exists. A crossing hands you the planet itself, or as much of it as light can carry. But crossings are luck, pure geometry. The accident of whether that distant road happens to run edge onto your line of sight. Most don't. So when the eclipse turned up in Spitzer's 30 hours, hiding in the data like a note slipped under a door, it meant the luck was suddenly, plausibly, in reach. The geometry that lets a planet duck behind its star very nearly promises the other crossing too. Astronomers worked out when the next one would come, if it came at all. The date fell on a February night, and the odd, lovely truth about a 12-hour crossing is that no single telescope on our turning planet can watch all of it. The event would outlast anybody's night. If the world wanted this gift, the world would have to take shifts, and the world took shifts. And here's the kind of astronomy story worth keeping, because the heroes are not the giant observatories. On the predicted night, telescopes across several countries turned toward the Great Bear and waited through their own local hours of darkness, handing the star westward like a relay baton. In a suburb of North London, at a small university teaching observatory, the kind of dome that spends its life showing students the rings of Saturn, an astronomer and two of his students tracked the star through the gaps in the passing cloud, catching the light with instruments many amateurs would recognize. In the hills of Spain, at a private observatory run by a devoted amateur-turned-professional collaborator, another camera did the same. In southern France, the professionals watched too, and between them, across that one ordinary winter night, they caught it. The star dimmed by about 1 part in 100, right on cue, and stayed dimmed, hour after hour, as 4 Jupiters' worth of silhouettes slid across its face. When the measurements were stitched together, there it was, the crossing, real, complete, confirmed within days by group after group. A world on a comet's blade of a road, 200 light-years away, had walked across its star while schoolteacher-grade telescopes in back gardens and campus domes quietly wrote it all down. The most brutal planet we've ever found was measured, in the end, partly by students, between clouds. It's worth pausing on how lucky that crossing is, and on the sly way the luck was earned. Whether a planet crosses its star, from our point of view, is a pure lottery of tilt. The road has to run edge onto our line of sight, near enough exactly, and the universe owes nobody that alignment. For a world on a wide, calm road like Jupiter's, the odds are dismal. A fraction of a fraction. Almost every planet in the sky slides forever above or below its star's face as we see it, invisible to this whole branch of science. So, a crossing world is already a winner. But here's the sly part. A stretched road improves its own odds. What matters for the lottery is how close the planet comes to the star, because a tight near turn sweeps the planet through a much bigger slice of possible viewing angles. By diving so absurdly close, tonight's world multiplied its own chances of being seen crossing, tenfold and more, over a calm road of the same size. The blade, the very thing that makes the planet violent, is also the thing that laid it open to study. There's a small poetry in that worth taking to bed. The most extreme road in the catalogue came, by its own geometry, gift-wrapped. The worlds that suffer most visibly, you might say, are the ones easiest to know. And everything we understand about this planet, we understand because its road tips its hand. Do you know what the Great Crossing actually looks like from down here, through a telescope, on the night itself? Almost nothing, and that's the wonder of it. No silhouette, no shadow you could see. The star stays a star, a shivering point of light in the eyepiece, and all that happens is that it dims. By 1 part in 100. Would you notice? If your bedside lamp did that, you would not. Nobody would. A passing moth costs a lamp more. The dip is invisible to the eye, and trivially clear to a camera that measures light by counting it, which is what all the garden domes and campus observatories are really doing on transit nights, counting photons from one star, minute after minute, and comparing the count against neighboring stars that shouldn't change. When the counts sag by that whisper of a fraction, and hold the sag, hour after hour, in the same shape from Spain and London and France, that sag is a planet. 4 Jupiters of world, read as a rounding error, verified in triplicate. There's a lesson folded in there about how much of modern astronomy works. The dramatic things almost never look dramatic. They look like a column of numbers leaning, ever so slightly, all in the same direction. The trick, the whole craft, is caring about the lean enough to sit up all night confirming it. Discovery, most nights, is diligence wearing a coat. That night upgraded this world from a curiosity to a laboratory. And it's worth saying plainly what kind of laboratory, because the universe doesn't hand these out often. Here is a single planet that, every 111 days, runs itself through the most extreme climate experiment imaginable, from deep chill to blast furnace and back, while conveniently crossing both in front of its star and behind it. Everything about the experiment can be timed, weighed, and thermometered from Earth. Nobody has to fund the experiment. Nobody has to schedule it. It reruns, identically, forever, on a calendar you could print. Want to know how a giant planet's air behaves when you heat it by 700 degrees in an afternoon? There's exactly one place to find out, and it fires on schedule like a lighthouse. Astronomers sometimes call worlds like this Rosetta Stones, and for once the grand phrase is fair. Most planets show us a single settled climate, one note held forever. This one plays a scale, top to bottom, every lap, and in the differences between its seasons hides the physics of every gas giant's weather, ours included. Jupiter keeps its secrets on a calm road at a steady distance. This world is Jupiter's wilder cousin strapped to a pendulum, and every swing shakes something loose that the calm worlds never show. And the laboratory has been busy ever since, in a quietly wonderful way. Nearly every lap, somewhere on Earth or above it, somebody is watching. The crossings get timed, year after year, by professionals and by that worldwide congregation of amateurs with garden domes and cooled cameras. The same tribe that helped catch the first one. The eclipses get measured from space. The warmth curves get refined. Each near turn is another rerun of the great experiment. And each rerun sharpens a number somewhere. The road's exact shape, the spin, the fever's height, the ring down of the bell. There's a particular charm in what that means practically. This planet has appointments. Its transits are published years ahead, the way eclipse tables are. On the appointed nights, people you'll never meet set alarms, open their domes into the cold, and spend the small hours guarding a 12-hour dip in one star's light, handing it westward, time zone to time zone, a relay that has now run for years. No one is paid much for this. Plenty aren't paid at all. The most violent world in the catalogue is also, quite possibly, the most faithfully attended, watched over at each of its ordeals by a scattered volunteer family with thermoses and cloud apps. And if you want one image of what our species does at its best with its telescopes and its insomnia, that relay is a fine candidate. So let's use the laboratory. Let's go back down into the plunge, this time not to gawk but to understand. Because what happens to that atmosphere in those 6 hours is a story with real physics for bones, and it's a better story once you can see the bones. Begin with the world's strange spin. Its day runs about 40 hours, and that number is no accident. A world on a stretched road gets gripped hardest at the bottom of the swing, and over ages, that grip has tuned the planet's rotation into a compromise, a spin that nearly matches its racing motion during the close passage. The practical upshot is almost uncanny. Through the fire itself, the planet turns to face its star at close to the pace of its own flight, holding roughly the same hemisphere toward the blaze through the worst of it, like a hand held steady over a candle at the bottom of every lap. One face takes the summer. Then, as the world climbs back into its long autumn, the tuning slips, the spin carries on, and the scorched face rotates away into the general chill to cool among the cloud decks. 40 hours, star to star. Whatever you call a day on a world like that. Its clock was set by the fire at the bottom of its year, and it keeps that fire's time even up in the cold, all autumn long, the way a bell keeps the shape of the note it was cast to ring, which means the world has two kinds of night. And it's worth feeling the difference. There's the small night, the ordinary one, the 20 or so hours of every 40-hour day when your side of the planet faces away from the star. That one you'd recognize. Dusk, darkness, stars, dawn. And then there's the great night, the seasonal one, the long autumn itself, when even the daylight hours are lit by a star so shrunken and far that noon is barely more than a bright dusk. Through the deep of the autumn, the difference between the small night and the small day narrows to almost nothing. 100 days of the world turning through shade after shade of dark, noon a lamp, midnight a cellar, and the stars out nearly always. If you were built to live there, you wouldn't fear the dark. Dark would simply be the address. What you'd know in your bones instead is the returning. Every year, out of that 100-day dusk, the light comes back. First as a warmer noon, then as a real morning, then as far too much of everything, and then it's gone again, and the dusk resumes. Light, on that world, isn't the normal state of things interrupted by night. It's the visitor. It's the thing that arrives, overstays spectacularly, and leaves. The dark is what's faithful. Now, the heating itself. When the flood of light arrives, it lands on the top of an atmosphere. And the top of an atmosphere is thin, fast, and quick to answer. The upper decks flash hot in hours, exactly what Spitzer's fever chart showed, but heat that fast has nowhere agreed to go. Air expands when it's heated. Heated on one side of a world and not the other, it doesn't just expand, it stampedes, pouring off the day side toward the night side along the fastest routes the globe offers. On your world, differences like that drive the trade winds. Gentle rivers of air born from the mild contrast between your tropics and your poles. Here, the contrast isn't mild. It's a wall. Hundreds of degrees between neighboring longitudes, assembled in an afternoon. And the stampede it drives goes hypersonic. The models fed with the real measurements describe a front of wind and compression tearing around the planet at several kilometers a second. A global shockwave, the atmosphere's version of the crack of a whip. On the night side of the world, if you could hover there, the first news of summer wouldn't be light at all. It would be sound and wind, the whole sky shuddering, the far hemisphere's fever, arriving as a moving wall through the dark, and then the glow behind it. The strangest dawn in the known universe, a morning that arrives sideways, roaring, once a year. The heat rewrites more than the winds, too. It rewrites the air's own recipe. Molecules are assemblies, and assemblies have temperatures they can survive. Heat a sky by 700 degrees in an afternoon, and you don't just move its air around, you take its chemistry apart. Fragile molecules get baked into fragments at the bottom of the dive. Sturdier ones trade partners, and the balance of the air, which on any calm world settles into a routine and stays there, gets shaken like a snow globe once per lap. Then, on the long climb out, in the cooling, the chemistry starts reassembling, partner finding partner, the recipe slowly knitting back toward what the cold prefers. But here's the fine print the models argue over. Reassembly takes time, and this world's calendar may not grant enough of it. Some reactions are slow in the cold, slow enough that the air may still be mid-repair when the next dive arrives to shake it apart again. If that's right, the atmosphere lives permanently out of balance. A recipe never finished, forever caught between what the fire did and what the cold intends. And that's a state of matter you cannot buy anywhere in our solar system. Chemists would give a great deal for a cauldron like that. It stirs itself, on schedule, and has for ages. And its contents are on public display every time the planet crosses its star with the light shining through. And the clouds, here's the part of the physics worth carrying to bed, the clouds are made of stone. A giant planet, this warm doesn't wear clouds of water. Water on such a world is a deep interior matter. Up where we've been hovering, the condensable materials, the things that can be vapor in the heat and droplets in the cold, are minerals. Silicates, the rock family. Iron, compounds you'd meet on Earth as dust and mountains float there as weather. Through the long autumn, as the world coasts cooling through the top of its swing, those vapors settle out into cloud decks, hazes of mineral droplets, stone mist, possibly drizzles of molten rock or iron settling toward the deeps. The models paint several versions. Then the world dives. The near turn flashes those decks back to vapor, every cloud in the sky unmade in hours. and the whole world's weather is wiped like chalk from a board. On the climb out, in the cooling, the vapors condense again, and the clouds rewrite themselves, fresh, from nothing. Sit with how strange that is. Every world you know accumulates its weather, season layering into season, ice remembering ancient summers. This world's weather has no memory at all. It is erased and begun again, every 111 days, a sky that reboots. Astronomers get to watch cloud formation from a truly blank page there. Physics running from first principles, with no history in the way, and that's a window nothing in our solar system will ever offer. There's one more thing happening at the bottom of the dive, and though it's invisible, it may matter more than all the fireworks, because it's the thing quietly deciding this world's future. Tides. You know tides from the sea's slow breathing, but strip the word down to what it really means. A tide is what anybody feels when gravity pulls its near side harder than its far side. The moon does that to Earth's oceans, gently, from 250,000 miles, and the water swells by a few feet. Now take a star, not a moon, and bring a giant planet within 1/10 of Mercury's distance. And the difference between near-side pull and far-side pull stops being a poem about the sea. The star's gravity grabs the planet's near face, measurably harder than its far face, and stretches the whole world along the line between them, needing a body 140,000 kilometers wide. The planet flexes. Its layers slide and drag against one another. And that dragging is friction. And friction is heat, dumped deep into the interior on every single pass. Squeeze a rubber ball hard, over and over, and feel it warm in your palm. That, planet-sized, once per lap. But here's the detail to carry forward, the one the whole last act of tonight turns on. That heat is not free, energy never is. Every degree of tidal warmth needed into the planet's insides is paid for from somewhere, and the somewhere is the orbit itself. The swing pays for the squeezing, which means the swing, imperceptibly, unstoppably, is running down. If needing a world with gravity sounds like theory, look one moon over from home, because our own solar system runs the demonstration nightly. Jupiter's moon Io rides a road only slightly out of round, but Jupiter is enormous and close. And that small, yearly flexing is enough to knead Io's interior like bread dough. The result is the most volcanic body known anywhere. Hundreds of active volcanoes, plumes of sulfur climbing hundreds of kilometers into space, a surface that repaves itself so fast it has no craters left, a moon glowing at the seams, and every joule of that fire comes from tides. Nothing burns on Io, nothing needs to. It is squeezed warm. The way your hands warm a lump of clay, by nothing but the arithmetic of being pulled harder on one side than the other. We've photographed it from close range. The proof is orbital, ongoing, and gorgeous. Now, scale the demonstration up. Replace Jupiter with a star 10,000 times heavier. Replace little Io with a giant planet. Replace the gentle out-of-round road with the most stretched planetary road ever measured, diving to kissing distance once per lap. The physics is identical, only the numbers grow teeth. Whatever the deep interior of tonight's world is like, it is being wrung, regularly, by the same hands that keep Io's lava flowing, and the energy for all that wringing is draining, pass by pass, out of the swing itself. How big is the toll? Per lap? Small? Almost insultingly small? One pass changes the orbit by less than any instrument on Earth could measure. Watch for a century, and you'd still catch nothing. The books balance so slowly that the planet's whole recorded history, every wobble and dip and fever chart we own, fits inside a single, unchanged breath of the process. So how can anyone claim the swing is running down at all? Because the physics gives no exit. The tides are real, we can compute them. The kneading is real, Io proves the mechanism one moon over. The heat is real, and heat must be paid for, and the only account open is the orbit. When a process is certain but slow, astronomy does what banks do. It stops watching the pennies and reads the interest rate. The rate says the road must round off, and deep time supplies the patience. A hair per lap? 3 laps per Earth year? For hundreds of millions of years, is a whole geography rewritten. It's the same arithmetic that lets a river cut a canyon with nothing but mud and mornings. Nothing about it needs to be visible tonight to be true tonight. The canyon is being cut while you lie there. You just live on a clock too quick to see it, which is, if you think about it, a fine thing to be too quick for. Hold that thought, because now we're finally ready for the question the whole night has been circling. Who wound the swing up in the first place? Start with what we know beyond argument. Planets are born in disks. We've seen the nurseries directly, on other nights, and in real telescopes, newborn stars wrapped in flat, calm wheels of gas and dust. Every world condenses inside that wheel. Inheriting its motion, which means every planet everywhere begins its life on a nearly round road, moving in its system's common flat plane, orderly as grooves in a record. Our own system still wears its birth order. So does nearly every system we've mapped. A world like tonight's, on a blade tilted out of any reasonable plane, is not a birth. It can't be. It's an aftermath. Something happened to this planet after it formed. Something that took a calm giant on a round road and hauled that road out to a blade, and whatever did it left fingerprints. One fingerprint you already know, the stretch itself. The second was found during those precious crossings, and it's the clincher. A star spins, one limb turning toward you, the other turning away, and when a planet crosses the star's face, the order in which it covers those limbs betrays the angle of its road. Watch this world cross, and the answer comes back steeply slanted. Its road doesn't just stretch absurdly. It cuts across its star's spin at a hard diagonal, a road knocked clean out of the old flat plane of its birth. Stretched and tilted, those two clues together rule out almost everything. And what they leave standing has been in the photographs all along. The twin, that second star, the quiet sibling hanging 1,000 Earth-Sun distances away, the porch light across the garden. 2 theorists in Toronto worked through the idea in the early years after the discovery, and what they found has become one of the most beautiful mechanisms in celestial mechanics. So let me hand it to you gently. In kitchen terms, the twins' pull on the planet is tiny, laughably tiny, far too weak to drag a world anywhere on any human timescale. But it never stops, and it always leans, subtly, in a direction set by the twins' own slow lap around the shared home. Now, a tiny push that never stops can't do everything. It can barely touch the size of the planet's orbit, its energy, which is why the road's overall span survives. What a patient sideways lean can do, given millions of years, is reshape and tilt the road it can't resize. It's the playground trick, truly. You can't shove a swing to the sky with one push, but stand there nudging it in rhythm, tiny nudge after tiny nudge, each one landing at just the right beat, and the swing will climb on its own schedule. The twin has been nudging for billions of years, and the mathematics of that nudging holds a wonderful, strange bargain at its heart. The roads tilt and the roads stretch trade against each other, cyclically, one growing as the other spends, so a planet's orbit under a leaning companion doesn't sit still. It breathes, over ages, tilting flatter and rounder, then steeper and stretchier, swapping the two back and forth like a slow figure being skated. Let the stretch phase of that cycle dip the road's bottom low enough, brushing the star, and the tides we just met wake up, grab hold, and refuse to give the loan back. The stretch gets locked in, the blade is forged. Here's a detail about that mechanism worth savouring. It wasn't invented for this planet. It wasn't even invented for planets. The mathematics of the leaning companion was worked out in the early 60s, decades before anyone had found a single world beyond our sun, by two scientists on opposite sides of the Cold War, working separately on entirely different problems. A Japanese astronomer studying why certain asteroids in our own belt ride strangely tilted, stretched roads, and a Soviet theorist calculating how the moon's pull would disturb the orbits of the first artificial satellites. Both of them, from opposite ends of the sky, derived the same secret. A distant-leaning third body trades tilt for stretch, cyclically, patiently, and can wind an orbit to extremes without ever touching its size. Their results sat in the journals for 40 years as a specialist's curiosity. Useful for asteroids, satellites, the occasional comet, then the planet hunters dragged home a world on an impossible blade. And somebody remembered that the drawer already held the exact tool, sized, sharpened, and waiting. The two theorists in Toronto fit it to the twin, and the fit was beautiful. That's a pattern you can trust the universe to repeat, and it's a comforting one, in its way. The answers are often written before the questions arrive. Somewhere in today's journals, filed under some modest problem, sits the solved mathematics of a mystery nobody has met yet. So here, reconstructed, is the biography of the most brutal planet we've ever found, as best our species can currently write it. It was born ordinary, a giant world, condensing out of a calm, flat wheel around a young yellow star, on a round road at a civil distance. Jupiter's story with different names. It could have stayed that way forever, and around a single star, it would have. But its sun had a twin, and the twin leaned on it, gently, forever, and over some enormous stretch of time. The tilting and stretching cycle worked the planet's road, the way weather works a coastline. Then came the age when the cycle's stretch ran deep enough to sweep the planet down past its star at kissing distance, and the tides took hold, and the long, free breathing of the orbit was over. The stretch froze near its maximum, the yearly fire began, and the swing started, hair by hair, to run down. That's who did it. Not a collision, not a wandering star, not some catastrophe with a date. The culprit is the quiet twin in every photograph. The weapon is a pull too weak to feel. And the method is time. In quantities only the sky owns. How sure is that verdict? Sure enough to print, not sure enough to close the file, and you deserve the honest version. The twin's mechanism fits everything we can measure. The stretch, the steep tilt, the tides now finishing the job, and the suspect is standing right there. But there's a rival theory, and it's a good one. Systems sometimes ruin themselves. If this star once raised two giant planets instead of one, the pair could have squabbled, as young giants do, swapping nudges across millions of years until one close encounter went wrong. In that kind of gravitational quarrel, one world usually gets thrown clear of the system entirely, while the other is flung onto, yes, a long, tilted blade. Same wreckage, different culprit, and the thrown sibling, if it ever existed, is long gone into the dark between the stars where no telescope can subpoena it. So the case stands as many good cases do. One suspect present, with means, motive, and a mechanism that fits like a glove. One suspect hypothetical, vanished, impossible to rule out. Most astronomers back the twin, some back the quarrel. Several suspect both had a hand in it. The quarrel first, the twin finishing the work. Tonight told you the leading theory, and it leads honestly, but the court of the sky keeps its files open forever, and somewhere in tomorrow's data there may yet be a fingerprint nobody has noticed. Gravity, they say, is the weakest force in the universe, and it is. It's also the only one that never gets tired, and tonight's whole planet is what that patience can build. You might be wondering, somewhere under the covers, whether anything could ever do that to us. It's the right question to ask a mechanism this quiet. And the answer is the good kind of no. The recipe needs a leaning companion, massive and bound and patient. And our sun simply doesn't have one. No twin, no distant partner star, nothing holding a permanent lean over our worlds. Astronomers have checked, carefully, more than once, because a faint companion was a genuinely live idea for a while, and the surveys that would have found it have come and gone empty. Passing stars do drift by over the ages, but a passerby is a nudge, not a rhythm. Gone in a cosmic afternoon, and the swing trick needs millions of steady laps of leaning to work its arithmetic. Our giants ride roads too round, too flat, too settled, and they've held them for over 4 billion years. Whatever wildness our system had, it spent early, before there was anyone here to mind. So when you picture the twin out there in the bare, leaning its featherweight lean age after age, picture it as a view into a fate our sky simply never ordered. The mechanism is real, the mathematics lives in our journals, and the nearest working example runs its course 200 light-years from your bed, at a safe and permanent distance. Some worlds get leaned on, yours gets left alone. The whole difference, and it's everything, is company. And now the toll booth from earlier pays off, because once you know the swing is running down, you know something almost nobody suspects about this world. The brutality is temporary. Every pass through the fire, the tides knead the planet, and the kneading bleeds energy out of the orbit. And an orbit losing energy does something very particular. It doesn't fall straight in, and its closest approach barely moves. Instead, the far turn sinks. The top of the swing comes down, lap after lap, epoch after epoch, while the bottom holds roughly its ground, and the long blade of the road slowly fattens back toward a small circle now, drawn tight around the star at what used to be the near turn. Astronomers can run this forward, and the forecast, give or take the enormous error bars of deep time, reads like the last page of a storybook. Over the coming hundreds of millions of years, perhaps longer, the long, cold autumn of this world will shorten and vanish, until the whole year is the near turn, a round racing lap of a few days, close in against the star. Permanent, steady, bearable fire in place of yearly catastrophe. A hot Jupiter, in the field's plain phrase, the most ordinary kind of strange world we know, thousands of the type on file. This planet is becoming one in front of us. We didn't find a monster in the end. We found a moment, a world caught in the middle act of being tamed, mid-swing, mid-transformation, and the odds of catching such a moment are the odds of photographing a coin in mid-flip. The universe flips a great many coins. This is the one we caught turning. Could we ever watch the taming happen, rather than just deduce it? Not here. Not in any lifetime. The toll per lap is far too small to clock, but the same slow surrender has been caught in the act elsewhere, and it's worth knowing. One famous hot Jupiter, a world already tamed onto a tight round lap, rides so close to its star that its remaining orbit is measurably decaying. Astronomers timing its crossings year after year have watched its year shorten by a sliver of a second annually, the first planet ever caught in the actual final spiral. Its far future is written and short, as stars measure things. Tonight's planet is that story's opening chapter instead. The swing still high, the toll still small, the countdown too slow for our instruments to hear ticking. But the ticking is there. Run the film of this system forward, and the frames are all known. The blade rounds, the autumn shrinks. The world settles onto its tight, hot lap and holds it for an age. And then, in some absurdly distant epoch, even that lap frays, because tides never do stop collecting. Nothing about it will be brutal by then. It will be one long, slow, orderly handing over, a world lowering itself, ever so gradually, into its stars' keeping. Deep time does not do cliffhangers. It resolves everything, gently, given room, and the wildest orbit we know is simply the part of that resolution our species happened to be awake for. And catching that coin mid-flip settles an argument much bigger than one planet, because the tamed thing this world is becoming happens to be the oldest riddle in the whole field. Remember the very first planet ever found around an ordinary star, the one from the French hills, the giant on the 4-day lap. Hot Jupiters, that family came to be called. Giant worlds pressed absurdly close against their stars, whole years shorter than your week, and they have been an embarrassment from the day of that first discovery. Not because they're rare, because they're impossible to build where they sit. A gas giant needs bulk, oceans of gas gathered fast, and the tight inner zone of a young system holds far too little material and far too much heat. Every theorist agrees a giant cannot be born on a 4-day lap, yet there they are, by the thousand. So they must be immigrants, worlds born out in the cold and moved inward afterward, and for 30 years the field has argued about the moving. Perhaps they drifted in early and gently, surfing the young system's leftover gas before it cleared. Or perhaps they came the violent way, thrown onto blades by siblings or companions, then caught by tides at the bottom of the dive, and slowly rounded off into those tight little laps. Both roads should leave traces. The gentle road leaves tidy, flat, round systems. The violent road leaves wreckage, tilted roads, lonely survivors. And astronomers checking hot Jupiters found plenty of them sitting on slanted, disordered orbits, the violent road's exact signature, around stars with distant companions, with no small neighbors left beside them. One honest aside about those thousands, because it reshapes how you should picture the galaxy. Hot Jupiters fill the early catalogues, not because the universe favors them, but because our instruments do. A giant world on a tight, fast lap is the loudest possible signal in both of the hunter's senses. It yanks its star hard and often, so the wobble is big and quick to confirm. It crosses a large face of its star every few days, so the dips are deep and constant. The first generation of planet hunting was, in effect, a net with holes of a certain size. And hot Jupiters were the fish that couldn't slip through. Quiet little worlds on calm year-long roads, worlds like yours, whisper where the giants shout, and they took decades longer and finer nets to find. So when you hear that the first planets we discovered were all wrong, all giant, all broiling, all strange, understand what that really measured. Not the universe's taste, our hearing. The galaxy, we now know from better surveys, is mostly quieter than its loudest residents, thick with small temperate worlds that no early instrument could have caught. It's a lesson that reaches well past astronomy, and it's a good one to fall asleep holding. The first things you hear from any new place are its shouters. The character of the place arrives later, with patience in the murmurs. What the argument lacked was a witness. Some world actually caught out on the violent road, mid-journey, and that's the seat tonight's planet fills. It is, as nearly as we can tell, a hot Jupiter that isn't finished yet. Every ingredient of the violent story is present and accounted for. The distant leaning companion in the photographs, the blade of an orbit in the wobble, the steep tilt against the star's spin in the crossings, the tidal fire in the fever chart, the slow taming in the physics. It's the middle frame of the film everyone had been arguing about from the first and last frames alone, and finding it turned a plausible story into a watched one, which carries a quieter, colder implication worth handling gently before we set it down. A giant that migrates the violent way does not migrate politely, a 4 Jupiter wrecking ball swinging across a whole system, twice a lap, for ages, clears the board. Any small rocky worlds that once kept calm roads around that star, any quiet neighbours on their own gentle laps, were thrown long ago. Into the star, or out into the endless dark between the stars, where, as we learned on another night, more worlds drift sunless than sit in any catalogue. Systems have histories, and some histories have casualties. When you look up at your own steady sky, with its giant planets parked politely in the cold and its small worlds safe on their round inner roads, you're looking at a system where the wrecking ball stayed on its hook. One reason your nights behave may be as simple as this. Your sun is an only child. And where do they all go? The thrown ones? You already know, if you were with us on the night of the Golden Telescope. They go to the dark roads. Every violent migration, every giant quarrel, every system that wrecks itself, sends worlds out of their systems entirely, unbound, sunless, falling forever through the space between the stars, and the surveys now suggest those wanderers outnumber the stars themselves. Some of them are giants like the vanished sibling our rival theory needs. Some are small stony worlds that once kept calm inner roads around stars like yours, evicted when their local giant came swinging through. Galaxy-wide, over billions of years, the eviction notices add up to trillions. It reframes the walk home from tonight, doesn't it? The gaps between the stars over your roof aren't gaps. They're roads, thick with quiet travellers, the combined lost property of every system that ever had a violent adolescence. And it gives tonight's planet one more shade of meaning. A world mid-taming is also very possibly a world with victims, and the victims didn't get a taming, they got the door. When astronomers weigh whether this system's blade came from the twin or from a quarrel, part of what they're really asking is whether somewhere out there tonight, on one of the dark roads, there's a giant planet coasting sunless through the black, carrying in its orbit the other half of this system's story. Let's stand on the calm side of tonight's world for a while then, since we've earned it, and ask what living under that sky through one whole year would actually be like, not the fire this time, the whole year. Suppose you could hover in the high clouds at the top of the swing, day one, wrapped warm against that hard winter cold. The night sky above you would be, and this is the part worth pausing on, completely normal, beautiful and normal. The same galaxy we live in, arranged into unfamiliar constellations, the same great river of the Milky Way pouring overhead. Stars in their thousands, steady and serene. 200 light years is nothing to the galaxy. Nothing about the neighborhood announces what the local road is like. And, through those normal stars, two particular lights, the sun of this world, coin-sized, honest, warm, and the twin, the quiet culprit, hanging among the constellations as a point of light bright enough to read by, casting the faintest second shadows behind you, an evening star beyond any evening star you've known. It would be lovely. That's the strange, essential truth of the place. For 109 days, out of every 111, this is a still, cold, starlit world where nothing whatsoever is wrong, where the two suns of the story shine like a lamp and a candle. You could fall asleep there every night of a long human life and never once be startled awake. The catalogues file it under extreme. The honest file card would say, mostly quiet. There might even be light shows, gentler ones, in the long autumn dark. A giant planet like this almost certainly carries a strong magnetic field, the way Jupiter does, an invisible bell of force wrapped around the whole world. And when the planet makes its close pass, it doesn't just take the star's light, it flies through the thick of the star's wind, that outrush of charged particles every star breathes. A field plus a wind is the recipe for aurora. If the models have it right, each near turn loads the planet's field like a storm loads a summer sky. Then, on the climb out, Through the cooling weeks, the poles of that world may burn with aurorae beyond anything Earth's skies have ever staged. Curtains of light rippling over the settling stone mists, the fire's last souvenir, dancing quietly in the dark. Nobody has seen this. Hold it as a maybe, a well-founded one, the kind of maybe that gets telescope time, but picture it anyway since you're already comfortable. The most brutal planet we know, 3 weeks past its ordeal, coasting up into its long, cold peace, crowned at both poles with slow green and violet fire. Its whole savage year softened, at the end, into curtains of light over an endless evening. Even the violence out there has a gentle aftermath. The universe rarely writes a storm without also writing, somewhere in the margins, what the calm after it looks like. You'd notice the missing things, though, if you stayed and watched with care. No moons cross that sky, most likely. A world that swings past its star at kissing distance can't keep them. The same tides that need the planet pry loose anything loosely held, and whatever moons it was born with were peeled away ages ago, which lends the nights there a particular emptiness ours never have. No rings either, for the same reason, just the planet, the stars, the 2 suns, and the calendar. And the calendar is the thing you'd feel in your bones, because everyone and everything on a world like that would live by one date. You'd watch the coined sun swell to a doorknob with a settled directness, the way coastal people watch the tide book. Nothing about the fall is a surprise there. It has happened, identically, for longer than Earth has had animals, and it will happen next lap too, right on time, and the time is knowable to the minute. That transforms the brutality somewhat, at least from bed. A catastrophe that keeps a perfect schedule stops being quite a catastrophe. It becomes a season, savage but honest. The world's one appointment, kept and survived, and closed out by the ringing of all that air settling back down into stone mist and stillness for another 109 days of dark, calm, readable sky. There are worse deals on file. Some worlds we've met on other nights are brutal every single hour they exist. This one signed a different contract. Almost all peace, 2 days of fury, and never, ever, a surprise. Before we shelve the file, one act of honesty. Because this channel owes you clarity about how a night like tonight is even possible. No one has ever seen this planet. Not as a disk. Not as a dot. Not once. Every single thing you've heard tonight was read from the light of one modest star, and it's worth walking the chain openly so you can judge it. The star's sway, read in the rainbow's barcode, gives the planet's weight, and the blade of its road. That's bedrock, decades of laps, measured by rival teams who'd love to catch each other slipping. The crossings give its true size, and with weight over size, its density, its nature as a gas giant. Bedrock again. That dip has been timed from 3 continents. The warmth curves from the infrared telescopes give the fever chart, the 500 to 1200 in 6 hours, solid, published, replicated in kind. And then, past that, the winds, the shock wave, the stone mist, the drizzles of mineral rain. Those come from models, physics run forward inside computers, fed with all the bedrock above, and models are drawings, not photographs. Careful drawings, drawn by people who show their work, revised in public when new light arrives. But drawings, the honest inventory of tonight is that the road, the weight, the size, the fever, the twin, and the tilt are as certain as things get in astronomy, and the weather's fine details are our best current sketch of what such numbers must mean. Science's actual promise is not that every image is final. It's that you'll always be told which shelf each claim sits on. Tonight's biggest claims sit on the top shelf, and they were checked the best way there is. This world told us when it would cross, when it would hide, and when it would burn. And then it did all 3. On time, while we watched. That's the deepest kind of confidence science ever gets, and it's worth naming because it's the same coin in every field. A story that merely explains what you've already seen is cheap. Anyone can draw a curve through yesterday. The stories that earn trust are the ones that stick their necks out, that say, before the fact, stand here, watch there, at this hour, and you will see this thing that has never yet been seen. The wobble said a world existed, unseen. The orbit said it would duck behind its star on a date. Spitzer stood where the date said and caught it. The geometry then said it should cross the star's face 2 weeks later. And 3 separate telescopes stood in the cold and watched a prediction come true to the hour. In the dimming of a star, across a distance of 200 light years. Every successful appointment is another lock on the story. That's why tonight's tale of an invisible planet can be told with a straight face. And it's also, if you remember our night with the golden telescope, the other half of that night's lesson. When the sky keeps our appointments, we trust the book. When the sky breaks them, we rewrite the book, gladly. Either way, the sky is the boss. And the whole beautiful machinery of science is just our species learning, slowly, to take better and better dictation. And what don't we know? Plenty, and the open list is worth reading out, because every line of it is somebody's next decade. Does the world keep any moons at all, or did the tides truly sweep it bare? Unknown, leaning bare. Does it glow with those great post-fire aurorae? Unmeasured, so far. What exactly are its clouds made of? In what layers, and how fast do they rebuild after each burning? Sketched, not settled. How much has the yearly kneading warmed its deep interior, and is the planet fractionally puffed up because of it? Modelled, argued, unresolved. Was the twin the whole story, or did a vanished sibling throw the first punch? Open, as we said, perhaps forever. And the beautiful practical one, the one the new generation of instruments is sharpening its pencils for. Can we catch the air's recipe directly during a crossing, and watch that recipe differ between the calm season and the weeks after the fire? Nobody has done it cleanly yet. Somebody will. It's strange and lovely, if you stand back, that a world nobody has seen still holds this many secrets after a quarter century of devoted watching, but that's the usual ratio in this business. Every answered question buys 3 better ones. The file on this planet has never been thicker, and it has never been further from finished. So, the crown. The title of tonight calls this the most brutal planet we've ever found. And you've been patient. So, let's test the claim against the competition, because the catalogue of worlds is not short on horrors, and a fair crown has to be earned. There are the pulsar planets, the first worlds ever found beyond our sun, discovered years before the Geneva team's giant, and they orbit a dead star's spinning corpse, bathed in its lighthouse beam of radiation, worlds outliving their own sun's death. There's the world whose day side runs hotter than the surface of many stars, where the air itself is torn apart, atoms stripped to fragments in a sky brighter than furnaces. There's the world where the models say clouds of iron vapor drift to the cooler night side and rain molten metal, weather you'd need a foundry to imitate. There are the lava worlds, small and dense with oceans of melted rock and atmospheres of vaporized stone, and the unlucky inflated giants caught boiling away into space, streaming their own air behind them like comet tails, whole planets evaporating on a schedule the telescopes can watch. That's the shelf this planet competes on. Every one of those worlds outdoes it in some raw dimension. Hotter faces exist. Stranger rain exists. Deader skies exist. And still, tonight's crown goes to the quiet star in the Great Bear, for one reason that all those others miss. Every world I just named lives its extremity as a climate. Constant, settled, permanent. An oven is only an oven. Nothing on those worlds is ever about to happen. But brutality, real brutality, the kind the word actually means, isn't a temperature. It's an event. It arrives, it peaks, it passes, and the whole weight of it is in the arriving. Only one world we know of has weather with a fuse on it. Only one runs the whole scale, piece to fire to piece, on a printed schedule, forever. Plenty of planets are furnaces. Exactly one, so far, is an ambush. And in fairness, before the crown is final, home deserves its honourable mentions, because our own solar system entered plenty of candidates in this contest. Venus, where we spent one whole night together, runs a permanent crushing oven under acid clouds, no schedule, no relenting, 90 atmospheres of forever. Neptune, serene and blue at the bottom of the garden, hides the fastest steady winds of any world we own. Jupiter wraps itself in radiation belts that would end an unshielded visitor in hours, and wears a storm older than every nation on Earth. Even your own gentle world, seen from the wrong angle, makes the list. Hurricanes broader than kingdoms. Winters that buried continents under ice a mile thick. And, over your whole sky each day, a star detonating hydrogen at a rate no bomb has ever approached, at exactly the right distance to feel like warmth on your face in a garden. Brutality, it turns out, is partly a matter of address and schedule. Every world is somebody's extreme, and still the crown holds. Because all of home's monsters share the one mercy tonight's planet lacks, or the one dullness, depending on your mood. They are constant. They are climates. Nothing at home rears up out of 100 days of calm to multiply the sky by 1,000 before lunch. For that, in all the catalogue of every world our species has ever weighed, you must go to the bear, to the quiet yellow star, to the swing. It's fair to wonder why we do this at bedtime, of all hours, this cataloguing of the sky's worst weather. Here's what the habit is really for, or what it's for tonight. Naming the extreme does something gentle to everything that isn't it. Sailors have always known this. You learn the worst sea in the pilot book, the one straight with the standing waves. And every other harbour in the world grows a little safer by comparison the day you learn it. Children know it too. The named monster, looked at directly, in a warm room, with the lamp on, shrinks to the size of its description. That's what the most brutal planet we've ever found is worth to you at this hour. It's the far end of the shelf. It marks the outer limit of what years can be, and by doing so, it quietly measures yours. However this week has treated you, your sun did not swell. Your air held its temperature to within a coat's worth. Your road stayed round to a precision no instrument in your house could even detect. The worst weather in the catalogue is 200 light-years away, aimed at nobody, on a schedule, softening by the millennium. You can check on it any time. It will still be there, still keeping its appointments, still far away. That's the whole transaction. You give the monster a name and a shelf, and it gives you back, by comparison, your own quiet night. And even the ambush, remember, is a phase. That's the last fact I want to hand you before we put the file away, because I think it's secretly the gentlest one in the whole dossier. The taming is already underway. The toll is being paid at every pass. Come back in some hundreds of millions of years, and the long autumn will be gone, the blade rounded off. This world will be circling its star on a tight, steady, respectable little lap, one more hot Jupiter among thousands. Its yearly fire settled into something constant and calm, a hearth instead of a wildfire. Whatever beings sweep the sky in that far era, with whatever instruments they've built, will find nothing remarkable here at all. A giant on a close round road, wobbling its star as smoothly as breathing. They'll never guess. The wildest road in the catalogue will have healed over completely, the way a river straightens its own bends given time. And the only era in which this world is a wonder, the only stretch of eternity in which its swing hangs high and its fire keeps its savage yearly appointment, is a sliver of deep time, and your whole species happens to be awake inside it, with telescopes. That's twice tonight. The universe has flipped a coin and we've caught it turning, and it's worth saying what that pattern really means. It isn't luck. Exactly. The universe is so large and so old and so busy that every kind of fleeting moment is always happening somewhere. Build enough eyes and you start catching them. The sky is full of mid-flips. We've only just begun to look up in time. So let's bring it home the way we always do, because home is where the story lands softest. Tonight, over your roof, if you live in the north, the Great Bear is up there somewhere, wheeling its slow wheel around the pole star the way it has over every sleeper in the north since sleepers first named it. It never sets, that shape. It just circles, all night, every night, the sky's own patient clockwork. And in through the side of that constellation, past the reach of your eyes but well within the reach of the binoculars in your cupboard, a modest yellow star is doing what it always does. It's shining steadily on a twin it has kept for billions of years, and on a planet it will spend the next billion slowly forgiving. As for the planet, here's the honest weather report tonight. This actual night, as you lie there. The odds are all on calm. Out of every 55 nights you could pick, 54 find that world coasting somewhere on the long, cool side of its swing, the star a well-behaved coin in its sky, the stone mists settling, the winds long spent, nothing due for weeks. Somewhere out there right now. In other words, it is almost certainly a still, cold, ordinary night on the most brutal planet we've ever found. The fire is real, and the fire is scheduled, and the schedule is mostly empty. If that world can spend its year drifting calm and unbothered under 2 suns and a settled forecast, you can certainly manage one night under 1 moon. And the swings will go on, whether anyone minds them or not, on a schedule that shrugs at every human calendar. By this time next year, the world in the Bear will have made 3 more dives and 3 more recoveries, rung its bell 3 more times, repainted its stone skies 3 times over. By the time a child born tonight grows old, it will have swung well over 200 times, identically, punctually, not one appointment missed. Every telescope that has ever watched it will be a museum piece long before the planet changes its road by any width an instrument could notice. That's the timescale difference between its life and ours, and you can hold it either of 2 ways. You can feel small against it, which is the common choice and not the wise one. Or you can feel what the winterers and the lighthouse keepers of our other nights would feel, which is a kind of professional respect between keepers of very different watches. The planet keeps its watch. The volunteers with their garden domes keep theirs. The Golden Telescope keeps its own, 1,000,000 miles out. And you, tonight, keep the smallest and best one. The night watch over 1 warm bed, 1 set of slowing breaths, 1 ordinary human sleep, which is, of everything catalogued in tonight's whole story, the only entry that is soft, and the only one that dreams. And notice before you drift what tonight actually gave you. Because it wasn't really a monster story. It was a story about roads. Your world rides the roundest, gentlest road the sky sells, a road so smooth that its tiny yearly wobble went unnoticed for the whole history of civilization. So smooth you had to be told, tonight, that January holds your closest pass to the Sunday. Nothing is due to swell in your sky. Nothing is scheduled to fall. The pendulum you ride was hung. By luck and time, and a well-behaved giant or 2, almost perfectly still, and every season you've ever lived arrived on tiptoe, by tilt, by the mildest lean of a spinning world toward its light. You've been riding the calmest swing in the known catalogue your entire life and calling it ordinary. Let the far world keep the other kind. Somebody has to hold up the extreme end of the ladder, and it may as well be a giant with no one aboard, 4 Jupiters of empty storm, born to a job no living world could keep. It doesn't suffer. It doesn't wait. It just swings and rings and quiets and swings again. The sky's great pendulum, keeping deep time's beat over one corner of the bear, while the rest of us sleep in the flat, calm middle of our own gentle years. If the drift hasn't taken you yet, count it down with me, the way we counted the fleet on another night. Count the suns this world watches. The coined sun of day one, mild on the cold clouds. The doorknob sun of the closing weeks, brighter, patient. The handspan of fire at the bottom of the swing, 35 times too wide, gone again in a day. Count the twin, the quiet culprit, reading light strong enough for shadows, leaning its featherweight lean for another 1,000,000 years. Count the sideways dawn, the wall of wind and glow rolling round the night side once a lap. Count the stone mists, unmade and remade, the sky that repaints itself from a blank page every year of its life. Count the bell of all that air, rung once, humming itself back to sleep over days, the way you're humming yourself back to sleep right now. And count the toll, paid at every pass, hair by hair, lap by lap, the swing settling, the blade rounding, the wildfire banking itself down, over ages, into a hearth. Count the 2 pins and the loop of string, drawing every road there is. Count the students in the cloud gaps, the volunteers at their domes, the little telescope still trotting along behind the Earth. Count the reading light of the twin, patient over its enormous garden, and count the almanac's one red date, weeks away and none of your business, and all the calm black dates between you and it, and tonight's, which belongs to nobody but sleepers. Let the counting blur. None of it needs you. The pendulum out there will keep perfect time whether anyone watches or not, and the pendulum down here, the soft one, your breath, in and out, slower now, is the only timekeeping left on your list tonight. And if you want one last picture to carry over the edge, make it this one, the gentlest in the file. It's the long autumn out there, as it almost certainly is. High in the clouds of the great calm hemisphere, the winds have been asleep for weeks. The stone mists are settling, fine and slow, like dust in a shaft of lamplight. Overhead, through the thinning haze, the stars are out. The same galaxy you'd see from your own garden. And among them, the 2 suns of this world's strange life. One a small patient coin, one a brilliant reading light, both of them quiet. Nothing is swelling, nothing is due. The only motion anywhere is the long, smooth, silent coasting of the whole world up the top of its arc, the slowest it will move all year, the closest thing a planet on a blade ever gets to lying still. Even here, the universe keeps a bedtime. Even the wildest road in the catalogue has a stretch where everything just drifts, and the world is on that stretch tonight, and so, as it happens, are you. You can let all of it go now, you know. The blade and the bell, the twin and the toll, the stone rain and the 1,000 suns of noon, they'll all keep until morning. And past it. And past every morning you'll ever need them. Nothing tonight requires remembering. The bear will circle. The star will shine its steady yellow. The far world will coast on through the cold side of its year. Calm as a barge, its one appointment weeks away, and utterly none of your business. Your road tonight is a circle. Your tilt is gentle. Your season is arriving on tiptoe exactly as scheduled. And the only swing left moving anywhere in your world is your own breathing, settling toward the bottom of its arc, slow and slower and slower still. If you're still awake and you'd like one more journey, there'll be another one waiting on the screen to carry you onward. Otherwise, stay just as you are, tucked into the flat, calm middle of the gentlest orbit in tonight's whole story, while the sky's great pendulum swings for you, far away, right on time. The stars will keep spinning while you sleep. Good night.